Hey, what's up guys? Welcome to Software Engineering channel. This is Karthik. I'm kickstarting this YouTube channel with a multi-part video series. In these videos, I'm going to be implementing a network library from scratch. Why is that? As I have mentioned in my introduction video for this channel, one of the purpose for this channel is to talk and teach about writing a clean code. What that means is that I want to teach how to write a code that is stable, that is easy to maintain, that is easy to change, that is easy to test, and easily integrated anywhere. Things like that. Usual software engineering principles that any senior engineer or architect would be concerned about. I wanted to teach them. I'm not an expert, as I have said, I'm not an expert, but I would like to teach as far as I have learned. The the one way to do that is by just talk about theories for a long time, which is going to be boring. I don't want to do that, and nobody wanted to listen to a video that is talking about theories of software engineering. Instead, what I'm going to do is that I'm going to pick up a task that any engineer would do in their day-to-day work, and then I'm going to try to complete that task. While I'm programming, I'm going to I'm going to I'm going to speak about what are the reason behind the decision that I'm making, what are the principle behind it, what are the benefit that I'm going to get out of it. At least I'm thinking um, things like that, right? So it's going to be very conversational. I don't want it to memorize a script and then just uh, record a video with the memorized script. I want these videos to be natural. I want people to see me making mistake. I want people to see me making a bad decision and then course correct it, thinking out loud. I want people to see me, forget about the iOS SDK API and then Google it and copy paste in Stack Overflow. This is what we usually do in a day-to-day work. So I want people to see it. I don't want people to think that it's just a scripted video. I don't want that. So I think building a network library from the scratch um, would help me accomplish that. In this video, I'm going to talk about two different things. Since this is the first video, I'm not going to program it. There are two things I'm going to talk about in this video. One is the success criteria that we're going to define for the network library. Number two, a simple use cases that we're going to implement in this network library. The use cases may grow, but we have to start somewhere, right? So we're going to talk about that. These are the two things. So without a further any delay, let's dive right into Xcode. I have created a package called network. It's just a simple package. It has nothing in it. All it contains is the default file that comes with it. This has only one target, and for network, another test target called network test. I'm going to be renaming that network test to network unit test in the later down the next upcoming videos. But anyway, I'm not going to do that here. A simple package. That's it. It's the HTTP library. All right. So in terms of success criteria, these are the 4 success criteria that I think it would benefit the library. The first thing is that we wanted to obviously build a library that is stable. What that means is that I'm going to create a library that is not going to be destabilized by external dependencies. So right now, the network library do not have any dependency, obviously, because we don't have anything in it. Usually, as we integrate this network library, as the product grows, we may want to add more to it. One among them, a good example is that we want to log the network request and response somewhere, either in console or either in some other web platform we use. If you wanted to log it, we don't want it to usually logging mean that we just take the data and then put it in a buffer and then periodically send the data to server somewhere, right? That's what logging means. We don't want to implement that in a network library. So usually logging will have a separate library called logging, or whatever that you call it in your project. So we naturally going to import that logging library and then make use of the logging APIs. So if we do that, that is a typical way of doing it. If we do that, then we are creating a hard dependency between network and then the logging, right? So if something goes wrong in logging, then our network library also going to be appear as if like it is broken. So it's going to be destabilized by external entity. That's what I mean by. So I'm going to create this network library in a way that it does not need any external dependencies. If you read a book called, there is a book called Clean Architecture by Uncle Bob. I strongly recommend it. If you read that, some of the component principles they talked about, it all distilled down to this idea. So we have to avoid as much dependency as possible, or if we cannot avoid dependencies, we need to find a way to move this dependency out somewhere in a different library, or you have to define your own boundary and then inject that dependency via that boundary. When we say boundary, it's going to be confusing a little bit, but we will talk about that while we are doing the implementation and integration. But so for now, let's just keep it simple. We don't want this library, the network library, to have any external dependencies, right? It's going to be a standalone library. That's the first criteria. That's a good criteria. And then the second one is abstract public APIs. All the APIs that we're going to have, all the APIs, all the consumers are going to interact with our network library through abstract API. So this, we may not be able to see the benefit right away while we are building this library, but when we are integrating this library with feature modules or any other project for that matter, you will find having an abstract public API is tremendously helpful for the feature model. These are all integration tips and tricks, right? Having a public API, is going to it's going to help the feature model during the testing. So when they wanted to test, since we have the public API abstract, they can create a mock networking service in their feature model and write their test. That is one of the main benefit of it, right? That is the reason why we wanted to build abstract API, public APIs. That is the second goal. And then the third goal is I'm gonna want this library thoroughly tested. Usually I do 100% code coverage. I set the bar high and then go from there. Majority of the time I will not be able to achieve 100% code coverage, because if you wanted to test your library 100% in your 100%, that means the test execution has to reach every single corner of your code base. There are many times we will not be able to do it, but I do have experience achieving 100%, but with some tricks. I'm going to do that. I'm going to implement that tricks while we are writing the code. So for now, I think 90% code coverage is really good target. That's the third success criteria. And then the fourth and final one is I want all the unit tests to be executing the test synchronously. I don't want any asynchronous call in my unit test. All the test has to be executed synchronously. There are ways to do it. While we are implementing it, I will do that. You guys will see me doing it. In case for in few places we will not be able to avoid a synchronous call, even in that place, we want the test to be executed within 200 milliseconds. That is the maximum. Let's set that target, and then if we are able to achieve all these targets, all these four targets, goals, then we are good. These are our success criteria, right? All right, so let's talk about the use case. Before we talk about use cases, I would like to take a little bit of a time and then talk about why I am writing use cases upfront. Prior to this use case based approach, I used to think all the possible use cases a library should have, as if like I'm writing an open source library that is going to be used by n number of companies, n number of engineers. So I have to have all the possible use cases implemented in the library, right? That is how I used to think back then. What ended up happening is that I started writing a lot of dead code for the product that the product may not use. A feature engineers may not use all the use cases that I have written. They may use a specific part of the library and that's it, right? So this code that I have written ended up becoming a dead code. And this violates a principle called common reuse principle. This is also coming from a clean architecture. I strongly recommend anybody to read it. So what this principle in an essence states is that we don't want to ship a production code that is not going to be used by the consumer, that is not needed by the consumer, right? So how do we avoid that? One of the things I have noticed in my prior companies that the senior engineers and then the project manager and then the quality assurance engineer, they come together and then they will discuss about what is the possible use cases that the business need, not all the possible use cases, just the business need, right? They narrow it down. So they will list that down and then they will write a production code in order to fulfill these business use cases. As soon as they're done fulfilling these business use cases, they're going to stop writing any more code. That's it. If the business use cases changed or if we add more use cases, then they'll go and then add that in the code, in the library. That is how they solve this dead code related problem. I think it is a very, very effective strategy. So I'm going to make use of that. I started following that. I'm going to make use of that here as well, right? That's a little bit of an explanation, right? Okay, let's talk about our first use case. Given a network service, when a request is received, then the request is sent to the server, right? When a URL request is received, then we obviously wanted to send the request to the server. That is the first use case for any network library, right? Let's go to the second use case. The second use case is the other way around. Given a network service, when a response is received from the server, then the response is returned to the consumer, right? This other way around. We send the request, we're going to this time return the response back to the consumer. And third, and then the final use case is that given a network service, when an error occurred during the network call, then the error is returned with HTTP status code to the consumer, right? Since it's the HTTP library, we wanted to return the error with the appropriate HTTP status code. That's what we're going to do. So these are all the three very, very preliminary use case that any HTTP library should have, right? This use case may increase. Obviously, this is not an exhaustive list of use cases, but this will give us a good start, right? So these are the three basic use cases that we're going to implement. And that's it. So I'm going to stop here. Let's dive into the code in our next video, right? Thank you for watching. See you in the next video.